I'm Angelo Nico Katapang, a product applications engineer of analog devices. I have here on my desk the contents of the CN0503 kit, and I'm going to show you how to assemble the entire setup. For this, we'll need a Phillips precision screwdriver and some gloves so that we don't smudge the optical pieces. First, we're gonna install the magnets to the bottom of the tower base. It is important to ensure that the magnets are installed with their polarities in the same position, so I'm going to mark them to prevent confusion. Install all the four small-sized magnets at the bottom of the tower base. You might also need to apply pressure since the recesses have a very tight fit. Next, we'll have to install the tower base to the board by following the silkscreen footprint and aligning these holes at the sides. By applying light pressure, the tower base snaps into place. We secure the base in place by using 10 of the 0.5-inch screws and hex nuts. Here's a tip: insert all 10 screws and mount all hex nuts first, then tighten them one by one later. Once that's all done, we can mount the LED and photodiode boards. You can choose the LEDs with a wavelength suited for your application. As for me, I'll be mounting the LEDs I'll be using later to show you some of the basic applications of the board. In mounting both LED and photodiode boards, you'll need to fully push them down to the onboard male connectors. This is the 365 nanometer LED I'll place in channel 1. This is the 430 nanometer LED I'll place in channel 2. This is the 615 nanometer LED I'll place in channel 3. This is the 530 nanometer LED I'll place in channel 4. Next, we mount the fluorescent photodiode boards at the sides of the tower base. Lastly, we mount the 4 transmit photodiode boards. That's enough for the board. Now we'll be assembling the cuvette holder with the optical pieces. We'll start by adding hex nuts at the back of the slit for the beam splitter. This is the beam splitter, and this goes in the slit at the side. You don't need to apply pressure for this. The beam splitter will easily slide into the slit. Be sure to check the slit if there are stray materials inside. That'll stop the beam splitter from fully going inside. Also, only touch the sides of the glass when holding the beam splitter, as you may smudge the flat sides where light passes through. This is the beam splitter cover. We'll use this to secure the beam splitter in place by using the 0.7-inch screws through the 2 holes here. That's in place. Try shaking the cuvette holder if you hear any rattling sound. The beam splitter inside should be securely held in place. This here is the lens. We will mount this at the front of the cuvette holder. To do this, first we attach 2 hex nuts to the 2 recesses at the top and the bottom. Then we insert a 0.7-inch screw at the top and a 0.5-inch screw at the bottom. Although this doesn't come with the kit, I have here a neutral density filter and a narrowband filter. The cuvette holder has provisions for these two at the front of the lens. This is the cuvette cover. we will use this to cover the light path. First, we add a hex nut to the recess at the front. Use the 1-inch screw to secure the cuvette holder, cuvette cover, and lens cover. Now, we can insert the cuvette, but first, we will add a magnet to the recess at the bottom. There's also a recess at the back you can insert a hex nut in, and a hole where you can insert a 0.5-inch screw. This is to secure differently sized cuvettes in place. To properly position the magnet, you can use a pencil or other non-magnetic object to push it in place. Finally, we mount the cuvette. There are plug caps that come with the kit which seal the cuvette holder to avoid spilling the liquid sample inside. You just have to push it in place. The cuvette holder and cover is tightly fitted to the cuvette, and you may need to apply light pressure. The cuvette holder can be mounted to any of the 4 channels at the tower base. We also have a long pass filter we can add to any of the 2 recesses at the sides of the cuvette holder. This is for use in a fluorescence measurement. Now that we've assembled the entire kit, we can now use the CN0503 to perform optical measurements. You can check the links at the screen for more details on this. Thanks for watching.